Okay then. Now we are 32 attendees here, so we can start. For sure, all the guys that will join after that will miss this meeting will be able to see the recording of it on the same address after this event is over. So one more time, welcome to everybody. Welcome to our event, IoT in Action. Today we will light up an area that is very popular in our times. Almost all over the world is speaking about IoT. We are taking a small part of it, only building our smart home, and we will show you what you can do and how you can make your neighbors mad today. Okay, let's start it. Our agenda today is, first of all, intro. Then we'll have a bit of theory just to explain you what the IoT is based on. I'll present one system that I made here inside my home, and Zahari will present his garden, actually. And at the end, we will have a Q&A section, of course. We'll be glad to answer all your questions. When I said questions, in the right side of your screen, you'll have the Q&A section that you can open and paste your questions. We will answer them at the last slide of our presentation today. So let's get started. First, let's have a bit fun here. This is the advertisement that is from one Norwegian store connected with IoT. We had a lot of laugh with it. Just enjoy it.
Playing jazz.
Playing jazz.
Smoothie.
Making smoothie.
Calendar.
No meetings today. Remember, dentist at 9:30.
Fire off.
Fire off.
Open door.
Door open.
And we're gonna do one more.
Oh, yeah. Open door.
Wrong voice command.
Open door.
Wrong voice command.
Open. Open door.
Repeat that.
Open door.
I didn't understand that.
Hey, open door.
Play on the floor.
Get over the door. Open the door.
Wrong
Open the
voice
door.
command. Error.
Hey, William. With a rock. Open door. Open door. Open door. Open door. Higher.
Higher volume.
Higher.
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 Okay. So the most scariest thing is our home obedient or it's smart? Actually, a lot of people are scaring of this because something will control their life. And in this case, I'll suggest to have a plan B for sure without electricity, to be just a mechanical, and you'll be in control of all things that are at your home. But I think that the world is going in a different direction, and all the things that you can do with all the sensors inside and all the switches, you can make your life easier. For sure, if you have any fears, just keep plan B mechanical. Okay, let's go to the next hour part. It's what we need to know and what is IoT. When I started to build this presentation, actually, I found that IoT is based on the automation, and automation is known from the very, very long time. Imagine that in all the factories, they are trying to automate and to remove the people and replace them with the robots. I believe that this is the beginning, but in the last this decade of the previous century, Kevin Ashton is firstly announced Internet of Things. Why Internet of Things? Because Internet was popular at that time, and just he wanted to win a competition for one project, and actually he did it with this stuff. So what we are when we're talking about IoT is just simply a lot of physical devices all around the world connected to through internet to each other and sharing data. So when we are speaking for IoT, imagine that a lot of data is built just in the last second, uh, terabytes maybe or petabytes of data. So there are some concepts that we want to share with you. First of all, the smallest one is M2M, which is machine to machine. Actually, this kind of thing we have in our telecommunications, where two machines are connected to each other and just sharing the information. Then the industry came and they want to build all this concept and to increase it with all the devices and software that is in the industry, in a plant or something like this. Then IoT came, where physical objects are just linked through the wired and wireless networks and exchanging information. Then we have the internet as a concept where we people are communicating too. And in the same level, we have a web of things. This is all the information that is received from all the devices and connected to the World Wide Web. At the top, there is a concept for Internet of Everything. It's a bit strange for me because I believe that this diagram will increase, but I'm not sure what will be the next name, because actually if it's Internet of Everything, including us, I don't know what will be the next one. Maybe some aliens, or I don't know. So what are the environments? Because as I said from the beginning, communicating and collecting the information from all the sensors was known a long time ago, but first tries it was shared, the information was shared through the wires or LAN. Then coming to the Wi-Fi environment, there are a lot of different ways to devices to get connected. So first of all, well-known Wi-Fi. Their second one is a Bluetooth. I mentioned here BLE. I don't know how familiar are you with this. Actually, this is Bluetooth low energy devices, which are all the mouses, hands-frees, or keyboards that are on Bluetooth. If you take attention on them, it was something interesting. They are losing a small amount of energy from the batteries, and their battery life is longer than usual. So this is especially developed, the standard for devices that are low consuming energy. The same idea is in Zigbee and Z-Wave, which are the standards from especially small IoT solutions like home automation. I want to mention that in our days, the mobile network is increasing the speed, and this is a big one opportunity to use the speed for all the devices to communicate and to share their data. Because actually, I think that all the sensors are not change too much after their invention, but the environment is the thing that is increasing as speed, as connectivity, or as a stability, and so on and so forth. So let's speak about a little bit about network topology. A smallest one is point-to-point. Actually, we have one gateway node which is communicated with one sensor. There are this kind of solutions, but actually they are invented in the very beginning. After that, this increasement of the sensors is just a necessary thing that can be reached. So the star technology is coming where one gateway is communicating with all the sensors. The problem is that this gateway is actually, it's a bottleneck because all the sensors are communicating between through this gateway, and this moves the topology to the next mesh topology, which means that everybody is connected to everybody. Some of the sensors, as it's seen, I believe you can see my mouse, like this one, actually they're sensors again, but they have additional functionality that they can route or transmit the information from other sensors. In the mesh topology that is most popular right now, there are a lot of devices that you can exchange information, and the good one thing is that no matter if your gateway is on or off, these devices are still communicating between each other. So in case of failure of the gateway, your system will continue working and will continue to execute all the scripts and commands that you are set up at the beginning. Let's talk about the Zigbee. Zigbee actually, it's a strategy that it's invented in the beginning of our century, and actually 2006 was the last year that this concept was edited. This is the concept that many devices are communicating with each other. They are self-organized. They are using 2.4 gigahertz radio signal, and they are ultra low power. What it means? It means that one device is powered by a battery that is, for example, CR2033 for an year. You mean that you can forget about your sensor and its power for a year, which is incredible, I think. There is a library of applications because all these sensors communicating one to other, and they're exchanging information. And the important thing is that in this network, they can make commands one to each other. What it means, imagine that in this Zigbee network, you have 2 or 3 bulbs that can be switched on and off by a command, and you have one switch that is connected to the same Zigbee network. And in this case, even in case you don't have a gateway, you'll be able to switch your light on and off. All this is based by a small devices. Me and Zahari will show you after a few moments. So that's about Zigbee. Zigbee is an alliance. A lot of companies are taking part in this alliance, and they are building their their standards, how it's communicating, how it's working, and what are the standards regarding this. As you can see, here is Apple, Google, IKEA, SmartThings, Schneider. There are many others, 135 or something like this, participants in this alliance. So right now I'll give a word to Zahari to explain what is MQTT, because it's next one important thing that you need to know. Zahari?
Yes, thank you. Hello. And I'm going to talk about the MQTT protocol. It's basically a very lightweight protocol. It is of a type publish subscribe. So the way it works is it transfers messages usually over TCP/IP, and its main goal is to have a small code footprint and to use limited network bandwidth. It was developed in the I think it was in the 90s by a person from IBM and one person from Eurotech. One of the first implementations of the protocol is desert oil pipeline, and they used sensors to monitor segments of the pipeline to make sure it's working properly. And they used a connection to satellites, which at the 2000s was really expensive. So having that small footprint and limited network bandwidth ability for them was cost effective. And this made the MQTT protocol a very good fit for that problem. And well, a little bit about its basics. The protocol has 3 roles: a broker, a subscriber, and a publisher. Taking a look at a standard server-client relationship, the broker is the server. It is a broker engine. It's a software hosted on a device. It can be a small device, a low power device as the Raspberry Pi. It can be a big server, depending on the abilities of the broker itself. The broker is basically the relayer of the messages, and the other 2 roles, the subscriber and the publisher, they are on the client side. The client can take both of these roles depending on whether it wants to read data or send data to the broker. And it's basically it. The way the messages are organized in the broker, it's a directory type structure. For instance, if we want to have data gathered by sensors in a room, we can say /home/living room/ let's say temperature over the couch, for instance, and that would be the pipe where the messages from the sensor will be sent. And for instance, if we want an air conditioner to decide whether to cool the area or not based on that specific area, it can subscribe to that directory or topic and read what the sensor is sending and make a decision on whether the area needs to be cooled or heated. Some notable implementations of the protocol that are around for at least a decade are Facebook Messenger. It initially started with an MQTT broker. I wasn't able to find information if it still uses MQTT, but it's interesting to see such a big platform starting from something we can all download. We have Consort Energy. They are a home energy provider, and they used MQTT to monitor energy usage. And another very interesting old implementation is from 2006. IBM worked with medical institutions to create the cardiac patient care system, which allowed for patients using specific models of pacemakers or other cardiac monitoring devices to send data to their doctors, so that when they go to their routine checkups, the doctors will have very accurate data and make more informed decisions for the patients. And on the next slide, we're going to see some of the most common brokers there are. So on the left-hand side, we have brokers that can be downloaded and installed on premise. When it comes on the right-hand side, we have the cloud implementations from the biggest cloud providers. But when it comes to brokers, there is not a silver bullet for everything, at least in terms of on-prem solutions. Most of them, they have their drawbacks and their pluses. For instance, one of the biggest drawbacks of some of them are one of them is a single-threaded broker, and if you're limited, if one of your thread is limited to 3 gigahertz, that's pretty much it. You can't go above it. There are security issues with some of them. Some of them don't support SSL. And some of them have a strange total connection limit, which compared to others is absurd. So when picking a broker, it's usually a good idea to research all the options well and to compare depending on what your use case is, so that you can pick the best one. On the cloud side, we have a solution from Microsoft, from Google, and from Amazon. Respectively, from Microsoft, it's Azure IoT Hub. From Google, it's the Cloud PubSub Hub, and from AWS, I believe it's called just IoT. And that's pretty much it. I think we covered connectivity. Now Peter is gonna say a few words about the home automation systems that can be used to make our lives easier.
Yeah, okay. Just 1 second, let me show myself. So we have a lot of solutions that are on the market now. We have paid one. We have some of them that are not paid, but are cloud solutions. Here I can say the Google Home, the HomeKit. This is from Apple. As far as I know, we have Tuya, we have EWE Link. Even Xiaomi has their own Mi Home. Some of you knows that I'm a fan. But all these solutions, we are dependent of the network because every device is connected through the internet to the cloud. So imagine what will happen if you build a smart home and somehow your internet connection is down. Everything is down actually. Then you need a plan B, as I said from the beginning. So on the right side, you can see the open solutions that are, of course, much more hard to manage because you need to read a bit more. But you have a lot of advantages. First of all, you are independent of the network. So everything is in your house, everything, including the data, including the decisions that are made. Here we have Home Assistant, the system that I'll present. Here we have Open Hub. The difference between them is that Home Assistant is written on Python, but Open Hub in Java. And actually, everybody of us prefer the different language. So it will be interesting for you maybe. Even Mozilla do web things. That is, again, home automation system, but they're I think they're much more in the beginning right now still. So we have, what do we have here? Okay, that's my turn now. So I'll explain what I have here at my home. First of all, let me show you the structure, but right now I'll hide my face because there are much more information that I want to share. Okay, should be better now. So this is my system. What I have a Raspberry Pi, which is a small one, a board computer with a processor of the smartphone. There I have a Home Assistant installed. And I am using two kind of networks in my home automation system. One is Zigbee network and one is clear Wi-Fi, well-known Wi-Fi. So on the Zigbee Connect controller, it's microcontroller that is programmed to be a part of the Zigbee network and to have a communication through USB to the home assistant. On the Zigbee network, as I explained earlier, there a mesh network that all the devices are communicating between each other, and all of them are reporting to the controller. I have a lot of devices connected here. First of all, I have bulbs that I'm controlling my light. It means they can be switched on and off. Then they can have different brightness from 0 to 100%. I have switches, different kind of switches that can switch your on and off your light. So they simply, by clicking, they are sending a command to Zigbee. And this command is interpreted by MQTT broker. There are different kind of switches, and I have a lot of sensors. Sensors for gas, sensors for movement, sensors for temperature, pressure, and humidity, sensor for leak. If I have some water on the floor, can be registered too. So all these devices are connected and communicating to MQTT. On the other hand, in the right side, I have, again, bulbs that are connected through Wi-Fi. IR receiver, it was interesting. I'm still working on it because actually I'm able to command all the devices at home that have remote control with IR. That was my idea because actually I have cooling air conditioner that want to be switched on and off or change the temperature. I have some sockets that can be used and like end devices. I have light switches and my favorite cleaner. Let me show you how they are looking. Actually, they are pretty small. As I said, with one battery, you can forget about them for a year. Here we can see a light sensor. Here is the temperature. Here is the movement sensor. Here is my core. Actually, it's a small one, 5 to 10 centimeters computer with a Zigbee stick. My IR receiver, my switches. Here is the gas detector. Of course, it's near the heating system, and he will notify me if I have gas in the room. So it's important for me. And let me show you how we are doing, how I'm working with this at home. Please give me a second just to change things that I'm presenting right now. Yeah, now you should be able to see my Home Assistant page. On the first page, but let me talk about it at the end. Actually, here I have all the add-ons connected to the system. So I have Mosquito Broker, which is MQTT broker, and I have Zigbee to MQTT. That is a program that is connecting to the Zigbee network and translate the messages to MQTT broker. And one, I have DNS service that allows me to, oh, I forgot to tell you that all this I have on my mobile because with this DNS, I'm able to connect to my Raspberry Pi from all over the world. So this DNS is taking care of connection through the internet. In the configuration tab, of course, there is an offer that I can connect to the Home Assistant cloud, but I prefer to do it right at my home. So I have some integrations here, which I'm integrating Xiaomi Gateway. This is Chromecast. Here I'm taking the weather. Here I'm connected to my mobile phone and MQTT as a broker. In the devices, you can see a lot of devices that are connected. All these are devices that are connected to the system. I'll explain it after that and I'll show you. Here are all the properties that I can see or command through the Home Assistant. And of course, I have areas. I have my balcony, living room, kitchen, halls, bedroom. What is interesting is the automations. Automations, it's very, very simply to do an automation. Automation, let me edit this one and I'll show you. Okay, here I have toggled light in my bedroom. So if the switch 1 receives the single click, no matter what is happening, without any conditions, just toggle my switch for the main light in the bedroom. I have 2 of the switches, one on my side and one on my wife's side, so everybody of us can trigger the light or can switch the light off. The other interesting thing is when we have movement. So I'm saying in next rule that if the whole one monitor sensor detects movement and the sun is below horizon, means it's nighttime, then turn on my lamp there. And with one other rule, I will turn it off. You can give, of course, some more readable name, but I'm only one that's reading this name, so I know what is written there. So, okay, same moving sensor. If stops to find some movement at the front end and the sun is below horizon, then just turn off the lamp. Of course, let me, here I have screens. I can do more scripts. That scripts are just following actions one after another, and I can trigger them as the end part. Here I have dashboards, people, zones, and users. Let me do a simple demo. So this is my main dashboard that I'm seeing everything at my home. Here is the status of Raspberry Pi. Is the power enough? So here is seen that we have a small break in the power. It means that it going below 4 point. Usually it's 5 volts, but it's going a bit below 4.8. Here is the updater. Here is the temperature of the device. Here is my living room. I can see the temperature and I can see how the temperature went to the last 24 hours. I can see how's the humidity going for the last 24 hours. Here is my balcony section. So I can trigger the light. I can see what is the status of the button there. And I have a few sensors. Here is my kitchen. It's again, I can see, do I have hot leak? Do I have gas? And is it okay and safe to be in the kitchen? Here is one, I'm calculating power, what is spent here with the computer. It's for today, it's about 0.3 or 0.4. Here is the hole, here is the, okay, let me show you what I can do here. So by switching the switch, I'll turn off the kitchen where I am right now. But for this, I'll need my camera to be presented. Just give me a second. Okay. I hope that you can see my screen and my face too. So let's show what is happening here. I'm switching the light. You see that the light is switched. So after a few seconds, this bulb is registered to the network and it's telling to the Home Assistant that it's turned off. Here I can turn it on and off again, or I can decrease the brightness. Here I can change from warm white to cold white, or even to change the color that is, I'm not sure that my camera is showing right now, but here's right now it's green, now it's red, now it's blue. Hope that you can see it. Actually, it's not so important for my living at home, but it's a lot of fun. One of my ideas was to make my whole lights to be switched on and turned red if I have something wrong with my gas in the kitchen or something like this. Everybody can think a bit, but most important thing is that these are simple automations. It's just making my life easier. But my idea is to collect all this data, because actually in the history here, we can see what is per 1 day, per 1 week, what is the status of all the sensors that I have. And my idea is just simply here. Let me show you. You can see all this information for 1 day, for 1 week, for 1 month. And my idea is to make some AI solutions or some AI analysis on this data and to predict something. But right now, I'm still in the beginning of this. So for sure, I'll have something to tell you after a few months. Okay, that was the important thing that I can share. One more thing, sorry. I see that we're getting a bit late, but here, what is the important? Important is that we can do programming by ourselves, all the sensors and all the all the components that are here, because here is the file editor that's simply connected to the file folder. So for example, here I can have custom components that are written by myself, and here with the simple structure I'm placing the simply Python code which is communicating with the gadget and is connected to all the structures of Home Assistant and can use all the data that is stored inside. So my idea is just to have something like this and to build my components inside this Home Assistant. Actually, that's a bit from my side. Hope that you enjoy it. Right now, let's go to Zahari, and he will show us what he did at home.
Hello again. So just to make sure my screen is properly shared. Okay. So my solution is a little bit. There's a little echo. Yeah, I muted you. Sorry. So my solution is a little bit more simple, but I hope it will be fun for you. I tried to make it entertaining at least. My solution is almost entirely based outside. What I have, just one moment, I lost my screen. So my architecture looks like this. My space is basically separated in two. Physically, I have a garden and lawn space and a backyard space, which is for hanging out. In those two physical spaces, I control two logically separate things, of course. In terms of the backyard, I control some lights, indoor and outdoor. I control a siren, which is sound and light. I do that via a relay board, which is connected to a Raspberry Pi, where I host OpenHAB, which is the Java solution Peter mentioned earlier. You see two Raspberry Pis. The board is connected to the secondary one. I do have a master one, which is the one I'm going to be using for my indoor solution as well. The master one will have access to everything. The secondary one is meant to be accessed by guests who can come here even if I'm not here, so that it can enjoy the outer space without they having access to the master one. The master one controls a lawnmower, which unfortunately I had to rig because I bought the wrong model and it wasn't able to connect to Wi-Fi. I also control a few valves which water my plants via drip irrigation and my grass via sprinklers. And I do have a floor heating, I forgot to mention, on the backyard part, because I have a small chill house, as I like to call it. And that's basically it. The way it looks, I just wanted to put a few funny GIFs here. The first GIF is the siren with the light. I do not have a sound, but it's better that I don't. Irrigation valves look like this, the sprinkler and the drip irrigation. There we have the funny robot, which I left open for you to look at some funny wires. And on the right hand side is the almost finished building and the lights. I'm going to do a little demonstration, a bit more limited, but I hope you enjoyed. This is how OpenHAB looks in terms of the configuration part of it. We have the add-ons, and it's basically the store. It's categorical. There are a lot of integrations and a lot of third-party software which can be used to do data tracking or other types of things which are not connecting to a Philips bulb, for instance, or something like that. They're just different things that can be installed, even different user interfaces. Here we have the configuration. The way things work in OpenHAB is you have your bindings, which are integrations with other things. Then you can register services. You can create things, and things is basically a thing. It can be everything. It can be a lot of things. In my case, I have an MQTT broker and an MQTT thing, which defines all my devices, which are controlled via MQTT. After I have all my devices defined, their topics and their IDs and everything, I can map them to things. And a thing is basically a switch or a text box or something containing data, or something that's an action. Of course, an action can be, as I said, a switch or a slider or something else. And once you set up all of this, an integration and a service, and you create a thing and you define your things, and then you map them to items, they become available for you to control. And you can write rules with them. The same way Peter showed. He showed a more advanced implementation. Mine is a lot simpler. What I have here is my watering, which is scheduled. But if you want to create a rule, you just say what is going to be the trigger. When is this rule going to be triggered? It can be a command. It can be when an item changes a state. It can be a fixed time on a date. When your trigger is triggered, you need to say what needs to happen. You can execute a script, run another rule which you have created, send a command, say something via voice integration. And you can also add constraints if you want this to not happen if something else has happened. And that's all I'm going to cover in terms of configuration. I'm going to show you my dashboard. It's, again, really simple. Currently, I mostly need to have things I can control myself, or I want rules for them to occur automatically. I'm going to make just something funny here. Just give me one moment so that I can share my entire camera. No, actually, it's not what I want to do. I want to share both my camera and my browser. I'm going to turn my camera to this window. And I'm going to mess up my window with a little water. I hope you can see it. Now I'm going to stop it. And yep, it's what I feel every time my watering starts. Of course, not at my window, but still. And that's pretty much it. From here, of course, I can control my mower. I can power it off. I can tell it to go home. And yep, that's my solution. There's a lot more to come, but this is how far I've gotten. And maybe I can show the presentation and go to the Q&A. Maybe you have questions and maybe we can answer them.
Yeah, thank you very much. So that was all fun from our side. We are enjoying it. Hope that it can be seen, and hope that it will become interesting for you too. Here we are to answer your questions. Actually, I'm checking and there is no questions in the Q&A. I believe it's opened, but let someone just send the test message then to be sure that it's working.
Whatever you want to ask. We expect it to be more uncomfortable and it seems we're not uncomfortable enough, so just shoot.
Okay then, we cannot see any questions, but you know us, you can reach us every time. We can show you in person maybe. So thank you very much one more time for the attention, for your time. Stay safe and stay healthy. Oh, there is one. Maybe it's a test message.
Yep, let's publish it.
Okay. Zahari, what do you think?
Well, it depends on what you want to do. If it's an indoor solution, if it's lighting or something like you said, simple, there is a budget way to go. If you're willing to wait 4 weeks from AliExpress, Peter knows the cost of most of the sensors and bulbs. Maybe he can comment on what are the options there.
Yeah, actually, if you're ordering them from AliExpress, for example, that they are not more than $10 per piece. Some of the gadgets you can find them here in Bulgaria. There are a few companies that are selling them. But as I said, you can start with something simple, maybe with one moving sensor, movement sensor, and one bulb that is, and it's not more than about 50 leva. Oh, you can, first of all, you can build your Raspberry Pi, which is about 50 leva. So I think that the simple solution is less than 100. Okay, so we have other questions. Let's take the one from Jordan. No, actually, the gas connector is not connected to the network. It was connected to the power supply because the gas detector is needing more power for it, especially this one. But it's cheaper. So this is the reason that I bought it, and I am using it. But it's not good. It's connected to the Zigbee network, actually. Okay, regarding the Wi-Fi, actually, Zahari, do you want to answer the Marin's question?
Yeah, sure. Like, if I'm interpreting it correctly, generally the devices that are available through Wi-Fi are more than the devices that are available only through wires. Usually there is always a wireless equivalent of something that can be controlled via a wire. For instance, a lot of the components that switch on and off electricity, they're relays or some sort of transistors depending on the voltage. And what they usually do, the wireless sensor just adds a controller. In my case, I use a cheap controller, which is called ESP32. You can flash an open source firmware on it, and it becomes a connected wireless device. A lot of the wireless devices that you buy out of the box, they have a similar way of doing things. They just have something that can be wired, but they just add the controller, which can connect via wireless, and you have a Wi-Fi connected device. If you're asking in terms of our setups, I'm 50-50. All my lighting and alarms are wired, and floor heating. For instance, my sprinklers and my mower, they're wireless. So I'm kind of a 50-50 scenario. The more critical things are wired.
Yeah, actually, if you're building your smart solution on a Wi-Fi, it depends of your router actually, because all the Wi-Fi connections, all of our Wi-Fi devices are simply connecting to TCP/IP in the internal network. But regarding the wire restrictions, Zahari just told that it depends of the device that is dealing with.
And the next question is really good. I like it.
Perfect one.
Who should start? You, me?
No, Zahari, please go on.
Oh, okay. In my opinion, the security is not mature enough. I personally find a lot of the solutions that are out of the box, they're using software that is not really mature, because I have reflashed a few of them, and I don't think it is a good way to go. For instance, if you have an outdoor sensor, which is Wi-Fi, and it's using a standard ESP controller, and it's a relay board, anybody that can access it can flash another firmware on it. And there are ways to actually download and recompile the prior firmware, and some people have done that. They have downloaded the bin file from the controller, and they have created a new one which has the credentials for the Wi-Fi, and it can just do rogue stuff on it on the network, just monitor stuff, things like that. But in terms of security, I believe there is a long way we can go. And actually, when we researched in terms of more industrial solutions and stuff like that, there is a lot of worry about it, because sometimes some gateways that are connecting to cloud providers, the way they host their cloud service, their custom cloud service, it's not secure enough, and you have a lot of a lot of devices connecting to these servers, which in terms of their own software are not really secure and can be breached. So a simple Google search for that can scare you, at least me.
Okay, let me share my thoughts too. I think that Zahari is right. There are a lot of way to go at the front of us, but a lot of people are going on this way. Actually, in Zigbee, you have certificates that are installed on every device, and there is an encryption into the network. For some of the Wi-Fi parts that I connected, they have a password that you should know to be connected to this device. In other case, we have the connection between MQTT and these devices is encrypted with the keys too. So people are working on it. I believe that we have a way to go forward, but right now the simple solutions can be done password or certificates encryption. So I believe that but this business is popular and the people are working on it very strongly.
The more we adopt it, the better it's going to become.
Yeah, actually we're trying to help them by taking part of this free solutions that are increasing the all the stability of the code, and we are trying to publish our work on these devices. So next question. The data, usually when we use, this is the question from Larissa, the data usually stored in the cloud solution, stored in the cloud. And if you are in the cloud, you are able to use all the tools that are there to make your analytics. In our solutions, we said that we want to be independent of the cloud, and the data is inside these small boxes. I especially made a cron job that is moving the data to external hard drive every night in 12 o'clock, and I have a backup of this data on external hard drive. But the data is locally in our solutions. Zahari, do you want to add something?
I'm going to sound a little stupid here, but I do not store my data yet. I'm too far in the beginning.
Yeah. There is a way to store it locally. Actually, with the MQTT, this data is not causing a lot of space, so it can be zipped because it's text messages actually. But we are trying to store it locally.
There's also integrations with the cloud. You can integrate it with databases in the cloud, and you can also do it with local databases you can host on your own. So there's that option too.
Yeah. Okay. And the last one from Peter, Zahari.
Well, if you go with out-of-the-box solutions for a fairly budget price, my personal opinion is that if you have a very good understanding what you want to achieve, you can do your research and installation, excluding waiting for shipping time, for around 2 weeks. If you have the time like to tinker with the things, I believe in 2 weeks you can have it working flawlessly, suiting your needs.
Yeah, that's actually my opinion too. For a week and a half or 2 weeks, you can build everything. If you want to have something smaller, but just pay attention on this, that it's very good toy, and you'll start spending your time for it for sure. Oh, okay. 2 more questions. Zahari, I'm moving them. I'll publish them.
Okay. The question from Zahari Barbov is, how much time did it took to for both of us to achieve the current state of our IoT smart home implementation. How much did it took you? It's a process usually, but
Yeah, actually, I started to work with this at home at my free time maybe a year ago. But it took me a lot of time to wait for all the gadgets from AliExpress. Especially now with this COVID situation, it's taking 2 or 3 months or more to get the gadgets here at my hands. Okay, then
just I want to answer on my side in a funny way, just to say I had construction and digging, so I'm not a good example of that, but what I did for like a year and a half. So that's my answer.
yeah, okay. Password break won't be enough. Yeah, okay. Right now, the certificates are there. You are able. I'm answering for the question of Alexander Andre. Yeah, you can have a manual certificate then to be installed on your devices, and they will communicate with it. You can do it. But there is one thing that is coming to my mind right now. Our world is preparing for a big one trouble because all the IoTs that are installed on the very beginning, their certificates will expire at the end of this year, and this is a lot of certificates. So they are planning right now what to do to not to stop the system while changing all the certificates. And there's a lot of things that need to be done in this area. So it's not too easy, especially for the security, but it's very important. Yes, you're right that it's important. And the last question that we have. That's,
A good one.
yeah.
So the question itself is, are the devices and more importantly the sensor trustworthy enough as of wrong sensibility? How we can be assured that some sensors won't start a fire in our house or wake us up at 3 a.m. Emphasizing on start a fire, not in literally, but figuratively. Yeah, well, I believe Peter has more experience with out-of-the-box sensors, and he can talk about that.
Yeah, actually, I had a funny situation on my side because actually I tried to use as a light switch in my bedroom and in my balcony one device that is that I'm flashing it, and I didn't flash it on the right way. So in 3 a.m. especially, the light of my balcony turns on, and it it stayed on till the very morning that I woke up. After that, I made an investigation and find what is the problem, solve it, and from this change, I had no more issues actually with the network. But you're right; it's scary if in 3 a.m. something is going wrong and your light in the bedroom is turned on. It's scary, yeah. But that's the risk of taking part of IoT project, I believe. Yeah, there is a risk. There is a risk, and we especially know exactly how to solve it. We need a QA environment, dev environment, and production environment. But right now, we are doing at home, just trying to do it at one environment. We know how to do it, but it's better to have three of them. Yeah. Okay, then we run out of time a bit because actually it was planned to 7:30. Right now it's 7:38. We have no more questions. Thank you very much for your attention. It was a great pleasure for us to show you what we did at home. And in case you have any questions, please don't hesitate to reach us and to ask us. We will help you to make your neighbors mad for sure. Okay, thank you very much. Yeah, thank you very much from my side, Zahari.
Yep, thank you very much. A lot of attendees. Hope you have a great night, and you know where to reach us.
Yeah, thank you one more time. Have a good evening and good night. Bye.
Bye-bye.